Well, over the last week or so, I performed an experiment right here behind me in my basement, and I recorded each step of it. Actually, it doesn't take very long at all. Most of the time was spent waiting for things to happen, like overnight. So I've got about 6 little clips here that I'm going to blend together and show you the whole sequence of events. And as part of that, you're going to understand a little bit better about solutions and concentration, and most importantly, about a process known as osmosis, because that's what the lesson here is about and what the demonstration is supposed to show you. So take a look, and then we'll see if we can process what happened. So in order to start this experiment, we're going to take an egg and some white vinegar, and I'm just going to pour the vinegar over the egg until it's completely covered, and it'll be submerged. Okay, so it kind of looks like that. And I'm just going to set it aside, and in about a day I'm going to take it and I'll show it what it looks like after a day. But what you're going to see is evidence of a chemical reaction happening between the shell of the egg and the vinegar itself. So now obviously it smells a little bit like vinegar, so I will put this someplace where it's not going to bother people. I'm not a big fan of the vinegar smell, so I don't know how it's going to be. I'm going to put it on this counter behind me. It's probably going to drive me crazy here as I work, but it's not like super strong or anything. You don't need to cover it. Just leave it open like that, and after a day, we'll see what to do, and we'll give you the next step. So that's a good start. Okay, so here's the egg after a day, and it's kind of hard to see this, but there's kind of a foamy top to it, and a lot of bubbles on the egg. You see the bubbles? Actually making it float. Those bubbles stick to the egg. So there's a chemical reaction going on there between the vinegar, also known as acetic acid solution, and the shell of the egg, which is made primarily of calcium carbonate. So we'll talk more about that reaction sometime, but I at least wanted to show you what kind of the second stage looked like. So I'm going to pour this off, and I'm going to put another fresh coating of vinegar on there, and it should finish the rest of it, taking care of that shell. So we'll see what it looks like in a minute. Okay, so here is the second, it's really hard to see that in the camera, the second pour of vinegar over here, and I'm going to dump this out. Kind of rinsing off the vinegar. Probably never seen an egg look like that before, but it's real soft. Just the membrane is what that is. So that's what we were after, to expose that membrane, because I want to show you how that membrane is able to let some particles through and other particles not. And we can actually change what's in the egg based on that. So that'll be one of the next steps. Okay, my next step with my egg, now it's been soaked twice in vinegar and rinsed off. Mine's been sitting for a little bit, but we can do this right away. So now I'm going to take some corn syrup. Now in the video that I saw, they used dark corn syrup, but all they had at the store was light corn syrup. So I'm going to completely cover the egg with corn syrup. And we're going to watch for a little while to see what kind of changes take place there, okay? So again, kind of hard for you to see, I know. And it'll take a little bit of time for it to do much, but we'll keep an eye on that, see what happens. So here's the latest progress with our egg. So when we last saw it, I had poured some corn syrup over one of the eggs where I had already removed the shell through that reaction with the vinegar. So I want you to notice a couple of things. First, look at the corn syrup as I pour it out of the cup. Okay, can you see that? Now I want you to compare that with pure corn syrup. What do you notice? I'm going to make a sticky mess here. You see the difference there? this is very watery. What came off of the egg is very watery, whereas this is very thick. So why is that? Well, it seems like there's more water in the corn syrup than before I had put it in the egg. Here's another little piece of evidence. Let me pour out the rest of this. So here's the egg. Now let me show you the original egg. Okay, this is what the egg looked like originally, and this is what it looks like. Let me rinse this off and I can show you a little bit better the difference here. Okay, so now I've rinsed them off. Now here's the guy that came out of that corn syrup. You see how kind of small, actually kind of shriveled up, and here's what the egg looked like just after we had removed the shell. So we got a shriveled up egg, and we've got very watery corn syrup. What would explain that? Well, they're both explained by the same thing. Some of the water that was originally in the egg actually went through the membrane and into the liquid corn syrup, making it more watery and the egg less full of water. Okay, so what we're seeing here is the effect we call osmosis. And why does osmosis happen? Why would the water want to move from the egg out into the liquid? Well, it's because the concentration of sugar in corn syrup is very, very high. The concentration of sugar in an egg is pretty low. So when we have things together, if a fluid can move through that membrane, it's going to try to make the concentration about the same in both. Now, I can't move the sugar from where I have a lot of it to where I have a little of it, because sugar can't go through that membrane. So instead, I move the water from the egg through its membrane and out into the liquid, and that has the exact same effect. It actually dilutes the sugar in the liquid a little bit, bringing its concentration closer to the concentration of the sugar that's inside the egg. Okay, so it's time for the last step in our little egg experience here. So what I did is I put some blue food coloring in some plain old water, and I'm going to take, this is the shriveled up egg, so I'll show you this again next to the other one. So you see this one right here is the one where the water came out of, so it's very shriveled up, much less volume than this is the original one that just had the shell taken off. So I'm going to carefully place it into the water. There we go. Whoops. I'm going to let that sit for about 24 hours or so, and then we'll take a look and see what's happened. Okay, well, here's the last step. So yesterday I put my shriveled up egg that I had previously removed the water from, that's why it was shriveled, and I put it in a cup with some blue colored water in it. Just otherwise it was just regular old water. So about a day later, and this is what it looks like. I'm going to put it in this cup so I don't have to hold it. So not so shriveled anymore, right? Let me let you compare it to the other one. This one is what we call the control. This is one I didn't do anything to, okay? And we are, and I know that's hard to see on the camera, but we're back to about the same size, right? So I have managed to allow the egg to reabsorb the water. Again, this is just the exact same process that got the water out of it in the first place. Remember, that's called osmosis. So now I had it in plain water, and so the concentration of the solutes inside the egg was greater. Well, remember that concentrations like to be the same if you've got solutions that are next to each other. And so that semi-permeable membrane around the egg allows the water to move in and out until those concentrations reach about the same level. Well, because the solute inside the egg was more concentrated, we needed to dilute it a little bit, and so that water traveled right into the egg to make a more dilute solution. Okay? And there is a limit to how much. Now, we still have more of the solute inside the egg than we have in our water. but we're at least closer to what we call equilibrium, or equal concentrations. So let's review that one more time. What happened when I put that egg with its membrane inside the corn syrup? The corn syrup, again, think of that as a solution very concentrated with sugar. So in this figure here, that might be like what we have here on the right. And then we've got a membrane. That's what this little purple dash line here is. And then this can represent inside the egg, where we also have water molecules. Those are like the little black ones. And we have a little bit of sugar, but it's not nearly as concentrated with sugar as it is in the corn syrup. So over time, we're going to try to make those concentrations the same. Now remember what I described about changing the concentration. You could either add solute to the solution to make it more concentrated, or you can take away solvent to make it more concentrated. Well, this membrane doesn't allow the sugar from the corn syrup to make its way into the egg. It can only allow the water that's in the egg to come out and into the corn syrup. And that's what we end up with here, where we've got more water now in the corn syrup, less in the egg, and that's why it's shriveled up. And we are not quite the same probably, but at least closer to being in what we call equilibrium. That means the concentrations of the two solutions are the same, okay? And then kind of the reverse happened when we put it in the water. We were able to force that water back into, through the semi-permeable membrane and back into the egg, okay? So the movement of the solvent, in this case water, in and out of that membrane to try to create the same concentration, that's the idea of osmosis.